The images you see generated by AI aren't just random pixels appearing from nowhere, they're the result of a process eerily similar to dreaming. These algorithms don't draw in the human sense. Instead, they learn the essence of images and then reconstruct them from pure visual static, revealing a profound abstract understanding of visual concepts often missed by human creators. This process fundamentally changes how we think about creativity and visual composition. In this video, we'll dive deep into the hidden mechanics, uncovering the core process that transforms words into breathtaking visuals, exploring the key components that make it all work, and showing you how understanding these principles can empower you to create truly exceptional AI art. So, how do these digital artists really work? At their core, modern AI image generators like Midjourney, Stable Diffusion, or dall-e 3 are built on something called latent diffusion models. Imagine you have a vast library, not of books, but of concepts. These models don't store actual images, they store an abstract, compressed understanding of what makes a cat look like a cat, or a sunset look like a sunset. This abstract conceptual space is what we call the latent space. It's where the AI truly thinks and understands visual information. The entire process unfolds in two main phases, training and generation. Let's start with training. Think of it like teaching a child. You don't just show them pictures, you point out what makes a cat, its ears, whiskers, fur, the way it moves. AI models learn similarly, but on an astronomical scale. They're fed billions of images, each paired with a text description. During this phase, the AI does something fascinating. It deliberately adds noise to clear images, then learns to reverse that process. Picture a clear photograph. The AI adds a tiny bit of static, then tries to remove it. Then it adds more static and tries to remove that. Over countless iterations, it learns what a noisy cat looks like, and crucially, what a less noisy cat looks like, all the way back to a clear cat. It's learning the steps to go from pure chaos to perfect order. This ability to denoise is the cornerstone of its creative power. It's also during training that the model learns to associate specific words, like fluffy, regal, or ancient, with visual features. This is often handled by a separate component, like clip, which ensures the AI understands the relationship between text and images, not just individual words or pictures. Once trained, the generation phase, or inference, begins. This is when you type a prompt, a cosmic astronaut riding a rainbow unicorn through a nebula. The first step isn't to draw the astronaut, it's to interpret your words. Your text prompt is sent to a component called a text encoder, which translates your human language into a numerical representation, a vector, that the AI can understand. This vector captures the meaning and style you've requested. Now, here's where the dreaming part truly kicks in. The AI doesn't start with a blank canvas. It starts with pure visual static, a random field of noise, like an old analog TV screen on a dead channel. This noise isn't arbitrary, it's specially structured within that abstract latent space. The AI then begins an iterative denoising loop. Guided by your text prompt's numerical vector, it takes tiny steps, subtly adjusting the noise, pushing it incrementally closer to what it thinks your prompt describes. Each step in this loop is powered by a critical component, the U-net. Think of the U-net as the artist's hand, constantly refining the image. It looks at the current noisy image, compares it to the guidance from your prompt, and predicts what part of the noise should be removed to make it look more like a cosmic astronaut on a rainbow unicorn. This isn't one big leap, but dozens or even hundreds of small, precise adjustments. The scheduler dictates the pace and intensity of these adjustments, ensuring a smooth, coherent transformation rather than a chaotic jump. Over many iterations, that initial static slowly begins to coalesce. A blurred shape emerges, then colors, then details. The AI is essentially reverse engineering the noise process it learned during training, but now it's guided by your specific textual instructions. Finally, once the denoising loop is complete and the latent image is sufficiently refined, a final decoder component takes that abstract latent image and converts it into the high-resolution visible pixels you see on your screen. It upscales the artistic concept into a tangible image. Let's break down some of the key components that give these generators their power. First, the clip model. Clip, or contrastive language image pre-training, is what allows the AI to see the world through language. It was trained to understand how images and text relate to each other. So when you say a cozy cabin, Clip helps the U-net understand what visual elements make a cabin cozy: warm lighting, a fireplace, perhaps a certain texture of wood. It's the AI's intuition for semantic meaning in visuals. Then there's the U-net itself, the universal neural network. It's designed to excel at identifying patterns at multiple scales simultaneously. This means it can denoise broad strokes and fine details in the same iterative pass, making the transformation from noise to coherent image incredibly effective. Without the U-net, the image would likely just become a blurry mess. The scheduler, as mentioned, is crucial for guiding the denoising process. Different schedulers can produce different artistic results, influencing how quickly or smoothly the image emerges. Some might lead to sharper details faster, while others might provide more creative freedom. Understanding that these parameters exist allows advanced users to experiment and fine-tune their outputs. Beyond these core elements, two powerful extensions are embeddings and latent. Embeddings are small files that capture the essence of a specific style, object, or even a person. They allow you to add highly specific concepts to your prompts without having to describe them exhaustively. Low-res, or low-rank adaptation, take this further. They are tiny models that can be layered on top of a base model to impart a distinct aesthetic or character, like a specific anime style or a unique photography filter, allowing for incredibly nuanced artistic control and specialization. Understanding this underlying mechanism isn't just academic, it has a profound practical impact on how you craft prompts. When you know the AI is denosifying a concept, you realize that your prompt isn't just a list of words, it's a series of cues guiding the AI's dream. For example, using negative prompts, telling the AI what not to include becomes incredibly powerful. If you don't want distorted faces, you explicitly state ugly, disfigured, extra limbs. This helps the UNet know which paths to avoid in the latent space. Another common mistake is treating AI like a human artist. If you say, draw me a dog, but make it blue, a human would understand that blue applies to the dog. AI might make the entire scene blue if you don't specify a blue dog. Being specific with your adjectives and nouns and using parentheses or weights to emphasize terms directly translates to clearer guidance for the denoising process. For instance, Blue Dog 1.3 tells the AI to really focus on blue for dog. Sometimes images come out weird or distorted. This often stems from biases in the training data. If the model primarily learned from images of people facing forward, it might struggle with profiles or unusual angles. It's not a bug in the AI's drawing ability, but a limitation of its learned understanding. Recognizing this helps you adjust your prompts or expectations. The future of AI image generation is constantly evolving. With new models emerging all the time, the fidelity, control, and creative possibilities are expanding at an astonishing rate. We're moving towards more multimodal systems where AI can understand and generate content across text, image, and even video simultaneously. The human role isn't disappearing, it's shifting from manual creation to conceptual direction and curating these AI-generated visions. By grasping how these incredible tools function beneath the surface, you unlock a new level of creative control and appreciation. You're not just a user, you're a conductor, guiding a statistical dream machine to bring your imagination to life. If you found this explanation helpful, consider exploring our other videos on cutting-edge AI developments. Just remember, everything here is for education, not personal financial advice. Your situation is your own, so do your own homework before you act. Stay curious. This is AI Unpacked.